Hello, Vaj. Welcome in my class, Water Resources Engineering. I, Dr. Pradeep Kumar Srivastava, welcome to all of you. Today's topic is the critical tractive force, regime of flow, resistance relationship for natural stream. Dear boy, first we will discuss critical tractive force. When a condition, the river trough, the river channel has a limit. Has a limit. Suppose, my dear boy, a river channel is showing like this. And position is just, and position is basin like this. Basin means entire the area which water he has collect, and after that river start to carry the water up to next big river or next to sea. My dear boy, in this channel, sometime high rainfall, a high intensity of rainfall has been created. So many water enter to this channel from here, from here, from here. So everything has a limit. The trough of river is also have a limit. And one condition, when it is river will flowing in its chamber area, then the problem is he is flowing smoothly. But when he is crossing to his limit, suppose what is limit? This is tentative his area. But when it's crossing the limit of this, suppose he entering to this area. So it had left his area, which he run regularly. Now, compaction zone has been ended and soft zone, this is the soft zone has started. This is soft zone. This is soft zone. It started. Where the water has started to flow. So a force, a resistance has tried to stop the erosion of soil, but maximum chances the force of water has been carry the soil of that area, and this force is called critical tractive force. Next topic is regime of flow. There are two type of channel in river. One channel is the regime channel, one mobile channel. So when we have convert with cement concrete channel, that is the rigid channel, and when the flow is flowing on the alluvial area, that it means mobile channel, and resistance relationship for natural stream, and these all forces has a key relationship, but which resistance is higher, that stream has changed its way, changed its capacity. So dear boy, today we will discuss about this topic. Topic is the critical forces, regime of flow, resistance of flow. Now we are starting. First objective on the critical tractive force. Estimation of critical tractive stress in the open channel is important for finding bank stability and for the design of suitable channel. It is also vitally need for finding bed load transport. Shear study is applicable for non-cohesive soil on flat surface. So Lane made extensive study on the critical tractive stress for both flat and inclined surface and contributed immensely for the design of stable channel. Thereby, all these studies are, however, applicable for straight channels only. Starting from fundamental, author has derived equation for critical tractive stress and both for stress and curve channel. It has been shown that the shear stress induced by secondary current in the typical curve channel, and that is in the meandering band, reduce significantly the critical tractive stress on the outer side of band. If the stress due to secondary current is very high, due to strong flow, curvature critical tractive stress may vanish and their outer bed and bank may cave in even with the in musician forward try. Next, on the regime chain, four regime are associated with different boundary condition. So three flow regime are usually identified: a steady state and issue to steady state and transit state. The flow regime depend on the boundary condition and it can be identified the rate of range and pressure with time. The steady state flow regime corresponds to a system in which the mass flow rate is constant everywhere and pressure is constant with respect to time. An example of system that exhibits a steady state flow, a reservoir conducted to an infinitic acting aquifer. The corresponding boundary condition is referred to as a constant pressure boundary. Next, some relationship for the resistance to flow over flat bed and dune bed in alluvial stream have been obtained by the regression analysis. So using flume and field data, in particular, a relationship for friction factor associated with grain resistance for flat bed with sediment motion, a power type of relationship for man velocity over dune bed, a relationship for the ratio of the mean velocity to the shear velocity due to bed form and relationship for a shear resistance due to bed form have been obtained. So now we will start rigid and mobile channel. Just I have explained that which condition convert to the rigid to mobile. In which condition? So we will discuss today on the condition. My dear boy, if you have make a artificial way nowadays, suppose river bank is a very high width. So somebody has taken measurement. In long 15-20 year river flow area is this. So they have make a channel. My dear boy, they have made a channel. They have given a proper way to flow in the river. And entire this area, they have converted a irrigation field. So now, if you have make a pakka channel, concrete channel, pipe channel, then the, the resistance, the forces will be not effective on the channel. This, which forces? These forces, these forces, these forces, these forces. So it will not erosion the boundary. It will not cut the boundary. Exact. But when a condition is not, when there is no proper channel, the condition will be made like this. One thing, when both channels are available in a place, suppose this is the comparative statement for your updating the knowledge. Here, a rainfall intensity is very high. So it can be water come from here, 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 here. Just I was telling in the river where they have SS 25-20 here, river flowing area is this is this. Then what he will do? He will do make a channel permanent. The flow has been channelized. And now flow will not expand in the rainy season also. Because and if it will be expanded in the high potential of the rain, then dear boy, maximum it will be come to like this, and main channel and the area of this will be few affected. This correct? But when now come in next channel. But when, my dear, this condition is implement for this area. If the intensity of rain is high, so entire this area is converted on a channel. And this boundary is called a mobile boundary. And this shape, which is this shape, think this picture, which is this shape. Now, this shape convert to this. What is difference? Entire this all soil and land have been abolished. Okay, so this is the main difference between rigid and mobile boundary. Now, rigid boundary channel we will discuss again. Channel whose bed and bank are made of non-erodible material. What is erodible material? First material, soil. The channel whose bed and bank are made of non-erodible material and can resist erosion satisfactorily. Resistance to water depend only on nature of boundary. So surface and it can be determined. Dimension can calculated by using uniform flow equation, that is morning and Cheg's equation can be used. Resistance to water depend only on nature of boundary surface and it can be determined. Dimensions can be calculated by using uniform flow. So equation, that is the Manning and Cheg's equation, can be used. Now, boundary is made up a loose soil which can be easily eroded and transported by flowing water. When just we have discussed in which condition after the high intensity of rain, the channel of the Nala and channel of the river had been exported and he had not under control to resist the erode the bed. So boundary is made up loose soil which can be easily eroded and transported by flowing water. That is river unlined alluvial channel. Thereby, resistance depends not only on boundary surface, but also one condition of bed and banks. Uniform flow formula is not sufficient for design, and stability depends on property of channel material. See this diagram, see this picture. This is all alluvial. In this, you are looking, just I am showing the unsafe boundary. See this is the unsafe boundary. This is now what is the position here? You can see the practical. These all alluvial. These all are alluvial soil. All are. These all are. These all are. It's a mobile. It's a mobile. In the rainy season, he will change his shape and mobile with the water. Now it transport water as well as sediment. And sediment and channel boundary material has some properties. It is stable if sediment inflow is equal to sediment outflow, channel bed remain constant. So snap, longitudinal slope and cross-sectional dimension depend on the discharge size of sediment and sediment load. Snap longitudinal slope and cross-sectional dimensions depend on discharge size of sediment and sediment load. So shear stress of distribution boundary. Here in a very good diagram of the shear stress distribution, and in this point it has shown the flow of water. The alluvial has changed its shape because no strength have in alluvial. It is a very poor and loose soil. But one thing, it is very fertilized soil. No project had taken guarantee to 100% in construct in alluvial soil. Now, shear stress distribution and channel boundary. And this is some formula. This is also formula. Now, incipient motion condition at low discharge with low depth of flow and small shear stress, sediment will be at rest with low depth of flow and small shear stress. Sediment will be at rest. And how? This is a drawing. Suppose, my dear boy, this is the flow. This is the flow. And this is the alluvial step. So this is the shear. Here, the change is here and the change here. in the three stages of shear force will be applicable on this, and what is the shape change? See that. So this will be made like this, and suddenly in the few hours it will be all mobile channel, all mobile alluvial will be run with the water. If when he get high flow, now shear stress is equal to critical shear stress, and bed practical diameter is equal to critical practical diameter. Shear stress is critical. Why critical? Because no way to save the alluvial. And bed practical diameter is equal to critical practical diameter. Critical practical diameter. Incipient motion condition video. Now introduction to tractive force approach. Average shear stress on the channel bed at which sediment practical just begin to move is critical tractive stress and critical shear stress. Approach assume and sediment particle resting on the bed in equilibrium due to balance in between drag and left forces exerted by flowing fluid. Submerge weight of practical and more relation and widely accepted. Now, introduction to shield diagram. Thereby, according to the shield, the tractive force extended by the following water on the sediment to cause motion is equal to boundary shear T0. So, tractive force or resistance to motion of single sediment. Dimensional ratio, in use this formula, and significance parameter and bed moment, grain diameter. S, Ys and Yw, a specific water of the sediment and water. So now shear Reynolds number. So Rn is equal to V minus D upon V square, where V is equal to shear velocity and small v is equal to kinetic velocity. Now we will discuss shear stress. The formation of river bed based on the shear stress. How formation of a river bed? How formation? Just you have seen. This is the river and this is the alluvial. And suppose water is flowing this area and this area. And one condition has come. So in this channel, pressure has developed and it has got width. So water quantum is just measured. So slowly, these deposition will be deposited. Now what had this way is locked. Entire one way is available. And under different condition of the sediment, size, fluid and flow condition. So up one thing, it is all corner forces. This, 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 now this, this, and this. This is the shear force of this channel. Now, different feature from on the bed under different condition of sediment size, fluid and flow condition. Characteristic of the different bed form and regime of flow. And where 0 to under TC, no sediment motion and bed remain plain rigid boundary channel. Now ripples. To greater than TC, TO greater than TC, so sediment particles start to move and small unsymmetrical triangular undulation appear on the bed known as the ripples. So length of undulation which are less than 0.4 meter. Height of undulation is less than 40 mm. Sediment size is less than 0.6 meter. And sediment move by silting and prolonging and smooth water of surface and formed when for one substatical condition. Now dunes. We have come on dunes. The width increase in discharge ripples. Grow in the size with a flat upstream and steep downstream. Water surface not smooth. Some particle may remain in the suspension. So length of undulation is greater than 0.3 meter to sub-meter, and height of undulation is greater than 30 mm to some centimeter. So sediment erosion in US This is upstream. So downstream movement speeds mean stream velocity. Formed when a far is relative high unsustainable bed for and offers flow resistance in flow. This is the position of channel. Now anti-dunes with further increase and discharge sediment transport intensity increase symmetrical bed and water surface waves and sediment move downstream crest and the wave of upstream, and these undulation are anti-dunes. So waves grow steeper and break. So occur in the vertical flow and high sediment transport rate and how resistance to flow. Now we'll discuss what is a river of stream. Dear boy, what is stream? A river is nothing more than surface water finding its way our if it river land from a higher an altitude to a lower altitude and all due to gravity. Yes, how to begin? River or stream begin their lips as smaller creeks, often called the headwater, and these small tributaries run downhill until they merge to a bigger tributary, which continue merging from a larger river. So here we will understand what is the tributary. If there is a hillock, so some shear. If any barrier is not available to store the water, so all water will be back or around the mountain. It will come in the basin and all small river will be joined and come at like this. These small tributary run downhill until they merge from bigger tributary and which continue merging to form larger river. This is the photograph of a river. Now tributaries. In this diagram, you can better understand how the shape of tributaries. Small contribution are collected with the tributary. Now work upstream. The work upstream include erosion, transportation, and deposition. Now erosion, the cause of erosion, attrition, corrosion, and hydraulic action, chemical solution. Corrosion, grinding away of solid rock surface by particles carried by water, ice, and wind, and it is generally held to be the most significant from the erosion in river. The hydraulic action. Hydraulic action is a form of mechanical weathering caused by the force of moving water current rushing into a crack in the rock face, and the water compress the air in the check, pushing it right to the back. At the wave present, the highly pressured air is suddenly released with explosive force. And now chemical solution. The dissolving of minerals into solution. Most minerals have low solubility in pure water, and but rain contains carbonic acid, so that carbonic material dissolve readily in the acidic solution. Now, way of transportation. Stream transport the load and sediment in three ways. In solution, in suspension, and shooting or oiling. Shooting or rolling along the bottom bed load. How it will be rolled? Suppose it is the so like roll. It is developed like this. Now, competence and capacity. The competence of a river is the maximum particle size that it is able to transport, and the velocity of the river increase. It is able to transport larger particles, and so its competence increase. The capacity is maximum load a river can transport, and capacity will also increase with increasing discharge and velocity. Now this is the small chips, larger angular bed load, and upstream require high flow condition of the transportation and had traveled only port distance, and smaller sub 100 at the bounded bed load downstream, and size has been reduced by the attrition. So stream channel type. So within a single stream, we can often recognize three different channel types. These unique channel type develop in response to channel in the stream due to following reason: velocity, sediment texture, and stream grade. And stream channel type, narrow channel, channel located in the upper reach of many systems tend to be narrow with the moving particle beside and upper reaches of a stream in the mountain. And so you have listened my lecture, and I think you have received the knowledge. On this lecture, I have prepared a MCQ. So I will happy if you will give the reply of the MCQ. So just wait. A multi-purpose reservoir, question is, a multi-purpose reservoir is the one which is designed for the one purpose but services more than one purpose are planned and constructed to serve. What is correct answer? Correct answer is B. Planned and constructed to serve various purposes. Now, a rain gauge should preferably be fixed. Where fixed? Near the building, under the tree, in the open space, or in the closed space. So correct answer is C, in the open space. Now a repelling ground, just you read, is along a pointing upstream, a pointing downstream, a perpendicular to bank or parallel to bank. So what is correct answer? Answer is A. Pointing upstream. A hydroelectric scheme operating under head of the 80-meter well to be classified as. So what is correct answer? A, B, C, D. Correct answer is C, high head scheme. A heterograph is graphical representation of rainfall intensity and time or rainfall depth in time. What is correct answer? Correct is A, rainfall intensity and time. Now, a land is known as waterlogged. So, what is the correct answer? When the permanent meeting point is reached, or when the gravity. Correct answer, tell me. Correct answer is C, capillary range reaches the root zone of plant. And next is 70% index of waterness means what is condition? What is the means? It means what is the correct answer? So correct answer is B. Rain deficiency of 30%. Now a current meter is used to measure. So what is correct answer? Answer is A. Velocity of flow of water. Now next question. A deep well is always deeper than a shallow well. What is correct answer? Correct answer is B. Has more discharge than a shallow well. Next question. A current meter is used to measure the, where measure the? Correct answer is A. Velocity of flow of water. And next and last question. A divide wall is provided where? Anybody? So correct answer at the right angle to the axis of shear. Now this is the references where I have taken some material. This is references, the name of author, and thank you. We will meet tomorrow. Okay.